if you go to tunnels, configuration, tunnels, and you go to underlay, if you'll notice here on the right that when you click the status button, it will pop up a newly formatted and newly improved tunnel troubleshooting tab. If either side is offline, it's just going to throw an error at you. This means that one of the two sides that you were trying to query is not online. That's probably also why the tunnel's down in a lot of cases. So when you click that button, it's going to give you this dialog, and it will run through a bunch of stats. These stats are real time. They update as the dialog is presented to you. So for instance, the keep alives down here at the bottom, you'll notice that these will continuously update as the panel is displayed in front of you. There's a bunch of information that's on this screen, but there are a couple of leading indicators of problems that we can look for. One thing I want to call out here, and believe it or not, prior to this release, it was really difficult to see what encryption algorithms and protocols were actually being used for a given tunnel. I mean, this question would come up quite a lot, like, well, Adam, I set the tunnel is set to auto, or I set it to something specific. How can I confirm that the tunnel came up and was provisioned with the authentication and encryption settings that I configured? Well, you can do that now. For instance, in this case, it's actually provisioned with the lowest settings possible, SHA-1 AES 128. That actually probably wouldn't be what some people want to see, and this would indicate to them that they should go and explicitly set a better encryption algorithm or authentication algorithm for the label that you've specified. There's also a matching SA and passive SA. This has to do with the passive SA is the previous SA that was used. We have to maintain two because when we do IPSEC key rotation, it's hitless. There's not like the tunnel needs to come down for a second while we renegotiate and we bring it back up. The EdgeConnect preserves the current SA as well as the most recent one. So this screen is showing you what a good to go tunnel would look like. All green, everything's up and functioning, and we're in good shape. Now there are a bunch of situations in which things won't all be green. One condition that's quite common, you'll see a master flow entry will say invalid. This is not the problem, but more like an indicator of some other problem that happened that resulted in the master flow entry not being created correctly or being invalid. The master flow table is, if you ever wonder, like, why can't I see the flows? Why can't I see the actual tunnel flows in the flow table? If you ever noticed that, right? The flow table only shows you the data path traffic after it comes out of the tunnel. But you got to think, somewhere in the system, we're having to track the actual ports and protocols that are being used on the WAN side by the tunnels themselves. And so the master flow table is this behind the scenes state table mechanism that's used to keep all that straight. It's also used for natting. It does things that you wouldn't normally see in the user-facing flow table in the EdgeConnect. And if there are problems in the master flow table with the way that the entries are created or the way that it's set up, it will be indicated here. Another common thing, if you see unreachable on either side, for instance, in this case, it says unreachable here for next hop connectivity, and it says reachable on this side. This is actually kind of backwards. What this is saying is that Stockton Labs next hop is unreachable, and East 2 AWS next hop is reachable. And this, because it says to Jauregui Stockton Lab, that means that from this side to the other side, this is the east side, its next hop is reachable. But on the other side, from Stockton Lab, its next hop is unreachable. And so this should tell you why the tunnel's down. If we can't reach the next hop, then the tunnel certainly isn't going to be up. When we say a next hop is reachable, it truly means it's reachable. We do a layer 2, an ARP, to determine whether or not the next hop is reachable. So when you see unreachable for any of the next hops in the system, that truly means that the EdgeConnect could not ARP for the next hop and that it is down. Kind of making our way down, the NAT discovery table, this is actually quite useful. This has to do with the way the system figures out the public IP or the way the system handles network address translation. In many cases, for instance, in every cloud situation, the EdgeConnect itself will have a private IP on its WAN side, and that private IP will be NATed into an elastic or a public IP by the cloud provider. This happens in all different situations. If you mess something up in the NAT world, there are a variety of different indicators that might show up down here. One thing I want to point out is that this NATD running state thing here, if this says quiet or quiet 2, that means that it is in the back off period. There's a built-in mechanism by which if both sides are not receiving any packets from the other side, they will both back off. By default, it's 6 minutes. So the EdgeConnect will stop transmitting anything on the tunnel for 6 minutes. And the idea there is you stop transmitting completely so that any firewall state tables in between the two EdgeConnects can age out. Scroll down a little bit. If you don't see the entire view, there's this keep alive section. This is arguably the most useful part of the feature. If you click this little button here, it says stop or start keep alive counter, you'll notice that this little differential, this little value will show up, and it will show you, since you clicked the button, it will show you how many keep alives have been sent in each direction, how many were acknowledged and received and sent, and so on.